Hi, and welcome to the Unit 5 extra credit video for Learning Target 5.1. This is part 2. Just a quick reminder, the CFUs that you answered in this video on Edpuzzle will not be graded, but this is designed to help you prepare for the graded extra credit. Alright, we are continuing on with Learning Target 5.1, which is balancing equations. In the first video, we talked about how to read and interpret a chemical equation. Now we're going to talk about understanding that equations have to be balanced by the law of conservation of mass. So we'll start off with what the law of conservation of mass is. It essentially says that matter cannot be created or destroyed. That means that the amount of, or the mass of reactants that you start off with must equal the mass of the products that you end up with. So if you start off with 10 grams of reactant, then you should expect to get 10 grams of product. On the flip side, if you made 35 grams of product, that means you made it from 35 grams of reactant. So these two numbers should be equal. Secondly, in the same token, the number of atoms that you start off with must be the same number of atoms that you end up with. So if on the reactant side you had 12 carbon atoms, on the product side you should also have 12. So let's look at some types of questions that test your understanding of that. In this first problem here, we're looking at the relationship between mass of product and reactant, and those two needing to be equal. So they're asking you to fill in the information in the table. You'll notice that they give you 2 reactants and 1 product, and they give you the mass of the products, but one of the reactants you don't know the mass for. So remember that the total mass of the product must equal the total mass of the reactant. Now on the product side, we have a total of 10 grams. There's only one product, and there's 10 grams with it. So what do you think the mass of the reactants must be in total? Yep, it should be the same number. It should also be 10 grams. Now we know that one of the reactants weighs 3 grams, and so the other one, our question mark, well, what do you think it will weigh? 3 plus this amount must give us the 10, so that means that the mass of the O2 would be 7. And you can solve that using mental math or using inverse operations to isolate your unknown. We're going to do one more problem like this, and then you'll do a CFU. Okay, so taking a look at this problem, if you want to pause the video and try it out on your own, you can for extra practice, and when you press play again, we'll go through this problem together. All right, in this case, they gave us the mass of both of our reactants. It's just the product that we're missing one of the masses for. So we're asked, according to the law of conservation mass, how much zinc is produced. All right, let's see if we can figure that out. Let's start off with finding out the total mass of reactants. If we add the mass of the calcium and zinc carbonate, 64 plus the 192, it gives us a total mass of reactants of 256. So based on that number, the mass of reactants is 256. What do you think the mass of the product should be overall? That's right, the total mass should be 256. And so with that being said, we know that this plus that must be 256. So the 152 plus the unknown mass of zinc should be 256. And again, for this, you can use mental math to figure out what the mass of zinc, or you can use inverse operation by subtracting both sides by 152 to isolate your unknown. In either case, you'll find that the mass is 104. Okay, now you're going to try a similar problem, CFU. So you're going to fill in the information, missing information here. After you enter in your responses, the answer will be revealed. Great. All right. Before we move on to the next part, I just want to give you a moment to sort of summarize what you've learned here about the law of conservation of mass as it relates to finding out the mass of a reactant and product. So you're going to take a moment to summarize what you've learned so far. Let's move on now to balancing equations. So in this video, as I said in the first one, I'm actually not going to show you how to balance equations here. There's a great video for that. That was your homework a couple weeks ago. The purpose of this video is for you to sort of get a sense of what it means for an equation to be balanced under the understanding of law of conservation of mass, which says the number of atoms on the reactant and product sides must be the same. So a couple key terms we'll be using are coefficients and subscripts, and you may remember that from video 1 or from your own knowledge. Coefficient is the big number in front, tells you how many molecules or substances you have, and then the subscript tells you how many atoms. That's the small number. That's the subscript, tells you how many atoms you have in that molecule. So for balancing equations, the thing to remember is that the way that we do it, the process of making sure that the number of atoms on the reactants and product side are the same, is we balance things by changing the coefficients, not subscripts. So if you give an equation like this right now, there's no number written here, so you presume that it's 1. Remember, if there's no number in front of the coefficient, presume that it is 1. It is 1. So those are the numbers we're going to change. We're going to change the numbers in the front. We're not going to change the small numbers because if we do that, we actually change the molecule. And we don't want to do that. We just want to change the amount of molecules that we have. Couple things to note as well is that coefficients cannot be 0, and that's because if you have a 0 coefficient, that means that molecule does not exist in that reaction. So remember, if there's no number written here, it's not 0, it's 1. That's right. Other thing is that the coefficients cannot be decimals, so you can have 0.5 or 1.5 or 3.2 as coefficients. We don't use decimals. And the reason why we don't use decimals is because if you interpret this chemical equation as being molecules, like molecules of O2, you can't have a half of a molecule because it's no longer that molecule. So that's why we don't use decimals when we're balancing. So no zeros, no decimals. Final thing, that the coefficients must be the smallest possible numbers, or the coefficients must be simplified. So let's take a setup number like these, 2, 4, 4, 10. Now, if we were to plug this in, 2, 4, 4, 10, it wouldn't balance the equation, but let's say that it does, 2, 4, 4, and 10. So if you're looking at those numbers, you're thinking, okay, great, everything is balanced. But we can't use those as a coefficient because these numbers are not the simplest numbers. If you look at all these numbers, you can divide the 2, the 4, and the 10 by 2. So we can simplify it by dividing everything by 2 and getting these numbers, 1, 2, 2, 5. So it's the 1, 2, 2, 5 that would be correct, not the 2, 4, 4, 10. So they must be the simplest numbers. All right, so let's see if this equation is balanced as is. Right now, we're assuming that the coefficients, and since there's no number here, everything's a 1. So we'll start off with the carbon. We're going to just tally up how many carbon, hydrogens, and oxygens we have on the reactant side, and then compare it to the number of carbon, hydrogens, and oxygens we have on the product side. If they're equal, the equation is balanced. That means that all the coefficients here are 1. And if it's not, we're going to have to change the coefficients to get them to balance. So for this first one, for carbon, on the side of reactants, we have 5 carbon atoms. Let's move on to the hydrogens. There are 12 of them. And oxygen, there's only oxygens here, and there are 2 atoms there. So these are the total number of atoms: 5 carbons, 12 hydrogens, and 2 oxygens. And notice that right now, since they're the coefficients, the number here are 1, I'm just using basically the information from the subscript. On the product side, we're going to do the same thing. So we'll start with carbon. There's only 1 carbon. Here from the water, there are 2 hydrogens. Now the oxygen's a bit tricky because we have oxygens in CO2 and H2O. So there are 2 in the CO2 and 1 in the H2O. So 2 plus the 1 give you a total of 3. Okay, looking at these numbers, are they the same? We have 5 carbons and 1 carbon. No, those aren't the same numbers. So automatically you know it's not balanced. But it's also true for the rest of them. Hydrogens and oxygens, not the same on both sides. So this is not balanced. It doesn't follow the law of conservation of mass. So one of the problems that you got on your quiz and on your practice quiz was basically trying to figure out which coefficients would work from a list of coefficients. And what I'm going to do now is I'm going to plug in the correct coefficients here. And then we're going to see what makes this equation balanced. So it should be 8 here, a 5 here, a 6 here. And what is the number here if there's no number? Right, 1. So remember, there's no number there. It's technically a 1. Let's see why this works. And this will also help you to see what to do when you have a coefficient in front. How do you count the number of atoms? Let's start with carbons again. There are 5 of them. Notice that there's a 1 in front here. And the only carbon on the reactant side is in the C5H12. So in total on the reactant side, we just have 5 carbons. Same thing is true for the hydrogen. We just have 12 of them. They're only found in this first molecule, C5H12, and the subscript tells me that they're 12. Now let's move on to the oxygen. Now we have a coefficient in front of 8. That means we have a total of 8 O2s. Since we have 8 O2 molecules, you can actually draw out the 8 O2s. If you've done video 1, it gives you a sense of what that should look like. And if you were to do that, you would know that in total, since there are 2 oxygen atoms in each O2 molecule and you have 8 of them, you have to multiply these two numbers. And it gives you now, instead of having 2 oxygens, we have 16 on this side. Let's check out how much we have on the product side. So we're going to begin with the carbon again. In this case, the carbon is only found in the first molecule, CO2. And since we have 5 CO2 molecules, we're going to have to multiply this 5 with the 1 carbon here, giving you a total of 5. So now we have 5 carbons. We're going to try the same thing for hydrogen. Hydrogen is only found in water. Each water molecule has 2 hydrogen atoms. And so what we're going to do is we're going to take the coefficient and the subscripts for hydrogen and multiply them together to tell us the total number we have. We have 12 hydrogens, right? So notice that we did the same thing over here. We took the 8 multiplied by 2 gives us 16 oxygens, and the 6 multiplied by the 2 over here will give us the 12 hydrogens. Finally, we have the oxygens. And remember, the oxygens are found in 2 separate ones, so we're going to have to do a little bit of extra math. So there are oxygens found in CO2, and since there are 5 CO2, we're going to get a total of 5 times 2, so 10 oxygens for this part. And over here for this part, we have 6 waters, so 6 times the 1 will give us 6. So 10 plus 6 will give us a total of 16 oxygens. As you can see with these coefficients, the 1, 8, 5, 6, it's balanced because all of the numbers are now the same. The same number of carbons, hydrogens, and oxygens on both sides. All right, in a moment, you're going to try a CFU with a similar problem where you're asked to figure out which of these sets of coefficients would work. Now, a strategy for this, instead of actually going through the process of balancing it, since they give you all of the coefficients, not just one of them, not just 2 of them, you're given all of them, you can essentially do what we did in the previous problem, which was like plug it in and see if we plugged them in, whether or not it would balance, right? The work we did up above. But a really good strategy is to cancel out any choices that cannot be correct, because what's the point of plugging them in? So remember, and I'll go back real quick just to show you, coefficients cannot be 0 or decimal. So if you see 0 or decimals, cross out that answer choice. And the coefficients must be the smallest possible number. So if you see something like 2, 4, 4, 10, where you can divide numbers by 2 or 3 or whatever, if it's not completely simplified, cross out that choice as well. All right, so here's your CFU. You're going to take a moment to answer it, and then after you answer it, the answers will be revealed. Okay, so here is the answer. So 2, 13, 8, 10, these coefficients work. And real quick, we were able to cancel out choice A because there's a 0 and a decimal. So the 0 alone means we can cancel it out, but having a decimal, definitely can't use A. Choice B has a decimal, so we can cancel that out. We didn't even have to try that one. Choice E, notice that each of these numbers can be divided by 2. So again, we don't want to use that one, so we can cancel that one out. That means the only choices we're going to try are C and D, and the only one that worked from those was choice C. When you plug choice C in, you'll see that the number of carbons, hydrogens, and oxygens balance out. If you're having trouble, what I would recommend you do is I would recommend you try this again now that you know the answer, and plug it in and see where you went wrong with adding up the number of carbon, hydrogen, and oxygen on both sides. Maybe that was your error, or maybe you forgot some of the rules. And it's a good idea to have those rules written down. All right, so this video is not going to show you how to actually balance a chemical equation, but you need that skill for the extra credit. So there is a video called Chemical Equation Practice Problems, and that video you were assigned for homework a couple of weeks ago. So if you've done it before, you're going to just do it again as extra practice. You can stop the video once you feel like you've got it. If you haven't done the video, you definitely want to do it, and you're going to go through the problems and try them out. Hope you found this video helpful. Have a quality break. Oh, one last thing. Next steps. You want to make sure that you complete your extra credit graded practice, because that's what I'll actually be entering in jump rope. It's going to weigh as much as the quiz. You can use your notes on it, so whatever notes you took from this video or notes you had before, you can use your notes to help you out. All right, folks, take care.